चलिए मैं इस पे करता हूँ. So I was talking about the dynamic मैग्निफिकेशन फैक्टर. अब उससे ना तीन हम डिफरेंट चीजें बना सकते हैं. फ्रॉम we can make the from the dynamic magnification factors when plotted against as a function of the frequency ratio. So this graph was already explained, and this is basically u. And if you say that ut divided by p naught over k, and this function you say it as a dynamic response factor, displacement response factor इसको आप कह दें RD. Let's say this function which is used in the steady state harmonic response, it is called as RD. Now you take the derivative of this function and again compute that, and now the RD into the omega, this is called as RV. इसको आप RV कह दें. And now again you take the second derivative of this displacement response, and then again compute the RT omega square and call it as RA. So it means that from the displacement response we can make the velocity response, and then we can make the acceleration response. These are interlinked with each other such that the beta RD is equal to RV over beta, or beta RD is equal to RV, and RV is equal to RA over beta. These are interlinked with each other. And when you plot the RD as a function of beta, you get this response. When you plot RV as a function of beta, you get this response. When you plot RA as a function of beta, you get this response. The point is that in the structural engineering dynamic analysis, acceleration, velocity, and displacement are interlinked. So the point was just to get displacement. We were always talking, always discussing. Now watching the response of the velocity as a function of the time is obtained, and then acceleration response as a function of the time, and this is the magnification factors are plotted. And this is important. Reason is that displacement, velocity, and acceleration, all these parameters, when we are using, all these parameters are very important. When we are using the displacement, we are using the velocity, or we are using the acceleration, these are interlinked. And even when you are when you can plot the three function on single page. इसको कहते हैं फोर वे लॉगरिथमिक प्लॉट. कि आप एक ही ग्राफ पर एक्सेलरेशन, डिस्प्लेसमेंट और वेलोसिटी शो कर लें. ये ऑर्थोगोनल है ऑल दो, दीज आर इन, ये भी 90 डिग्री एंगल है, दिस इज आल्सो 90 डिग्री एंगल. So this plot is available in your books, available on the internet. This is such a good graph that for any frequency ratio you can check the three things simultaneously. How you can check all the things simultaneously for any frequency ratio? So for example, if you see the one you want to see for this damping ratio 0.2, so you will go to this, you see the displacement response, you take the on this axis, you take the perpendicular on this axis. So all the three responses can be seen simultaneously. This is very helpful. I mean, for the practicing engineer who are working in dynamics, they can see all the three responses simultaneously from the four-way logarithmic plot. So this is called as the displacement response factor, velocity response factor, and the third one is the acceleration response factor. So now the resonance frequencies for the damped system, the resonance frequency can be obtained for the damped system. Thank you. So there are the three frequencies. Frequencies at which the larger response amplitude occurs is called as the resonance frequency. So these are the three responses: ut, acceleration, and this one. And we can set the first derivative of all these with respect to the beta आप निकालें अगर, and then put it equal to 0. So you can determine the resonant frequencies. आप निकाल सकते हैं. First you derivate every response with respect to beta और beta निकाल लें. So this will give you the frequencies at which the resonance occurs. Okay. Displacement resonance frequency, velocity resonance frequency, because the peak occurs for at different time. Displacement की peak किसी और frequency पे आएगी, velocity की peak किसी और frequency पे आएगी. And this one is basically the three responses, resonant frequencies. When you put down the value of resonance frequency or put down the value of 1, you can get the displacement response, velocity response, and acceleration response. So this is the response of the system at the resonance. Next one is the half power bandwidth. So the half power bandwidth is helpful in computing the zeta value. For example, we get the zeta value in the damped free vibration. तो damped force vibration में भी हम damping निकाल सकते हैं. कैसे? As told by the it is proved actually by the experts that if you plot the RD, displacement response factor, as a function of frequency ratio, you get this curve. Now you add beta is equal to 1. अगर आप बीटा 1 कर दें रेजोनेंस पे, आपका क्या आएगा? It is a resonance. So RD resonance is equal to 1 over 2 zeta. Now for half power bandwidth, let's say at resonance, for half power bandwidth, if you take the 1 by 2 under root of the resonance, अगर आप इसका 1/2 अंडर रूट लें एंड कंप्यूट द वैल्यू 1 माइनस बीटा स्क्वायर, इसको सॉल्व करें, further solve and simplification, you get the final answer in terms of beta a square and beta b square. Two roots आते हैं इसके, one in terms of plus and one in terms of minus, and then you take the difference of that and you get 2 zeta. इसको जब आप subtract करते हैं, and you can say that the zeta is equal to beta b minus beta a over 2. What is beta b and beta a? That is the frequency at this. Let's say the total frequency was beta. You take 1/2 अंडर रूट, इसका 1/2 अंडर रूट आप ले लें and draw the line. Here the two values will come. This is beta a, this is beta b. So taking the difference of that divided by 2, it gives you the damping ratio. So this is called as half power bandwidth. This formula is proved by this analogy, that if at resonance, you resonance पे आप plot करें and take the 1/2 अंडर रूट of that resonant frequency, और उस point पे जो frequencies दोनों आएंगी उनका difference divided by 2, you can get the value of the damping ratio. In case of the rotating machinery, जो force होगी, that will be slightly different. When the machinery is attached with the girder, this is a centroid, this is the eccentricity of the mass. So the force that I have shown you, P sin omega t, was the different force when you apply some loading. But when some machinery is rotating about any point, then the force will be different. So you can compute the force like that. And you can also, then in that case, the response of the system will be changed. Why it is changing? Because the force value is changing. When something is rotating on some beam or some, it is like some rotating machinery, it can be mill, it can be any kind of rotating material. The transmissibility or the support movement, and shifting to the support. Now, next point is that if there is no force applied to the system, but only the ground movement is present. सिर्फ अगर आपका ground पे movement आ जाए, this is a ground is moving. So you know that the ground का function क्या होगा? Ug is g sin omega t. This g is not the constant. This is the amplitude of the ground motion. Let's say मैं कहता हूँ कि ये 5 इंच मूव हुआ है ground into the, but the ground, अगर आप इसको sinusoidal मूव करेंगे ground को, तो function of the ground motion is g sin omega t, and acceleration will be the second derivative of this acceleration. This will give you the ground acceleration. Now the point is that there is no force. Force is zero, but due to the ground movement, the force will automatically be added. Which force? M into acceleration, because already this is the M into U is the force into the system, and M into UG is the force this is produced by the ground motion. So it means that when the ground is moving, MU, so this additional force M into UG, that is added, and when you take this force on the right hand side, it will be minus MUG, and this is equal to the mg omega square sin omega t, ये इसके बराबर होगी. So when the ground is moving, then this will be the force which will be acting on the mass, and you can compute this pt. It means that the force vibration, this is just like similar to the force vibration, but you will replace your force with mg omega square sin omega t, where g is the amplitude of the ground motion, value of this is a magnitude, any number, omega is basically the velocity of the ground motion, and so on, the t is the time. So you can put this value, and then this will be the response of the system in case of the ground motion. This will be the response of the system further simplified, and this is the phase angle in case of the ground motion. Now the point is that how much force is transferred to the ground, transmissibility. When any load is acting on the system, so the total displacement in case of the ground motion will be UG, the ground movement plus the regular displacement. So the ground movement is this one plus the other response of the system. So you will sum that to get the total displacement. That can also be written as this form. Here the phi and the rho is replaced by the gamma and xi and gamma, where xi is the amplitude, it is like equal to this for the ground motion, and gamma is the phase angle in case of the ground motion. Interestingly, when the amplitude ratio psi is the amplitude of the system and g is the ground motion, it is plotted, it is seen that with increase in the frequency ratio, again at about 1, it is we get the frequency ratio of 1, we get the peak response, but frequency ratio of the 2, suddenly the response is changing in case of the ground motion. So this at frequency ratio of 2, the response is going like that. So basically this function, the ratio of the amplitude or the force in the system to the ground, जो ground में कितनी transfer हो रही है, that is called as transmissibility. Transmissibility is the ratio of the force transferred to the building amplitude to the amplitude of the ground. इसको हम transmissibility कहते हैं. Taking the ratio of this to the G, it will give you the transmissibility. This is the formula of transmissibility. And whether it is a ground motion transmissibility or whether it is a transmissibility of the force, interestingly the same formula is there. अब ये force की transmissibility है, that you applied some force to the system and you want to see कि कितनी force support पे shift हुई है. So ratio of the force transferred to the support or ground to the force applied, this is called as transmissibility. So how much force is transferred to the support? Basically FD plus FS. मैथ्स की तो नहीं हुई ना, स्टिफनेस और डैम्पिंग ये लिंक्ड होती है ना सपोर्ट के साथ, तो stiffness plus damping is shifted, so in these two forces are shifted. Taking the sum of that, you know the ut, taking the derivative, putting the value of here u naught and u, और इनको अब sum करेंगे तो you get this is the force which is transferred to the ground. And now taking the ratio of the force transferred to the ground divided by the applied loading, तो ये transmissibility होती है. So in this case there was no ground motion, but you say that okay, some force is transferred to the ground also. When you applied some load on the building, how much is the force transferred to the ground? So taking the ratio is called as transmissibility. This is very important function which tells you that what was the force of the system that was applied and what is the force of transfer to the ground. तो यहाँ से आप फिर वो transmissibility निकाल लेते हैं. This is the ground motion transmissibility. कि अगर ground को move करें तो कितना shift होता है amplitude to the building and what is the ground motion, कितना difference आया है, and this is the transmissibility of the other one. So now you can have some problem, see the problem by the some different problem which are solved. Like this is a frame structure है, The frame structure supports a rotating machine that exerts a horizontal force at the girder. अब फोर्स जो है ये इस तरह दी होगी इन हार्मोनिक मोशन P sin omega t. So this is P, this is a omega and 5% damping. Steady state amplitude of the vibration. Compute the steady state amplitude and the maximum dynamic stress in the column. So amplitude चाहिए हमें कि कितना बना है आफ्टर अप्लाइंग द लोड. U वैल्यू जो एम्पलीट्यूड होता है रो वैल्यू इज डोनेटेड बाय द हैंडआउट्स एंड यू इन द बुक. ये बुक का प्रॉब्लम है. So you can you have all this given data. You compute the K value, the stiffness 3I over L cube, stiffness of the system because hinge है ना आपका नीचे hinge support है. That by 3EI और there are two columns हैं, दो column है. So K value and zeta is given. Now the static deflection आप निकालेंगे F naught over K. F naught is the 200. From where you see that this is the applied load, so F naught is 200 divided by the stiffness, you get the UST. From there you can get the period, natural time of period of vibration omega K over M, and then you get the frequency ratio. This is denoted by beta in the handouts, but it is R in the book. So omega bar is the frequency. ये जो ohm था ना ये book में in the handouts it is denoted by this ohm symbol omega, but it is denoted by omega bar in the book. So omega bar is the frequency of machine. ये कहाँ से आप देखेंगे? This 5.3, this value is basically the omega bar or ohm. This is the 5.3 value, so divided by the omega system की frequency. So take the ratio. This is also called as the beta or R in the book. Now you can compute the steady state amplitude. Steady state जो amplitude है rho or U in the book is equal to the UST P naught over K divided by 1 minus beta square whole square plus 2R zeta square. तो यहाँ से आप जो है वो इसका amplitude निकाल लेंगे, steady state amplitude of the system. And from that now you have the amplitude. Amplitude से आप force निकाल सकते हैं because stiffness is equal to the equal to carry out this is solve other problem also, which is so did you get that how the V is computed? Any student? How this V is computed? Did you get that?
सर जो स्टिफनेस है वो 3EI/L³ है, तो उसको हमने
हाँ, यू हमने निकाल लिया ना डिस्प्लेसमेंट। तो डिस्प्लेसमेंट क्या होती है? फोर्स ओवर डिस्प्लेसमेंट स्टिफनेस होती है।
यस सर।
तो यू की वैल्यू पुट की, सो वी आ गया। फिर एम इज कंप्यूटेड मूवमेंट इज वी इनटू द हाइट ऑफ द कॉलम, और मैक्सिमम स्ट्रेस क्या होगा? दैट विल बी द एम ओवर एम वाई ओवर आई। इससे मैक्सिमम स्ट्रेस आ जाएगी। इसी तरह मैंने आपको एक आई शो यू के कैसे आप फ्रीक्वेंसी निकाल सकते हैं। इफ़ द ग्राफ इज़ गिवन, रिस्पांस एम्पलीट्यूड आपको गिवन और फ्रीक्वेंसी भी, यहाँ से आप वो निकाल सकते हैं डैम्पिंग कैसे। पीक रिस्पांस आपको पता है इसका 1/2 कंप्यूट द 1/2 ऑफ दैट, एंड एट दैट 1.2 यू गेट दिस फ्रीक्वेंसी। ग्राफ से ही आपने खुद अप्रॉक्स लेने होता है, एंड टेक दिस फ्रीक्वेंसी, एंड डिफरेंस ऑफ द फ्रीक्वेंसी जो होगा divided by 2, that will give you the frequency, that will give you the damping ratio. The difference of frequency f2 minus f1 divided by the 2 value, that will give you the damping ratio. ये एक प्रॉब्लम है, divided by the sum of the frequencies. स्मॉलर वैल्यू के लिए 2 है, लेकिन ये फार्मूला है। f2 अगर आप यूज़ करें तो दिस वन इज द फार्मूला, so you can compute the damping ratio from that. This problem है कि machine is placed on the beam. A piston that moves up and down in the machine produces a harmonic force of magnitude. This force is produced by this machine. Any machine is produced on the beam. The frequency of this force is 60. So it means that omega bar is 60, F naught is 7,000. Neglecting the weight of the beam and assuming the 10% of the critical damping is ratio is 10%. Determine the amplitude of the motion, force transmitted, transmissibility भी आ गई इसमें, and corresponding phase angle. तो इसमें आप निकालेंगे, पहले K निकाल लिया बीम का, for simply supported beam 48 EI. You get the omega value, the zeta value, then the frequency ratio. आप frequency ratio ले लें, omega bar over omega, machine frequency divided by the system frequency 100. Machine frequency क्या थी? Omega bar was 60. So 60 by 100 is 0.6. The static deflection क्या होती है? F naught over K. F naught जो मशीन की फोर्स है 7000, K उसकी स्टिफनेस है, K आपने निकाल ली है, so you get the UST. Now you get the amplitude, U denoted by U here, and that is equal to UST over 1 minus R square or beta, R or beta square 1 2 R zeta square. यहाँ से आपका ये एम्पलीट्यूड आ गए और फेज एंगल आ गए. बट यू हैव टू कैलकुलेट द ट्रांसमिसिबिलिटी, जो मैंने आपको लास्ट पे बताया था. द ट्रांसमिसिबिलिटी इज इक्वल टू द फार्मूला जो उसका था ट्रांसमिसिबिलिटी का, हाउ मच फोर्स इज ट्रांसफर्ड. So this is the transmissibility formula, 1 plus 2 zeta beta square divided by this. So you can apply that expression here also, and you will get this transmissibility function. Transmissibility, it means that 1.5 times the force is transferred to the ground, and applied loading was 1000. So the total force transferred was will be equal to F naught into TR. F naught is, let's say, 10,000. so multiplied by the TR. So this is the force. F naught कितना था? 7,000. So 7,000 and the force basically transferred to the ground जो हुई है that is 10,827. यानी कि स्पोर्ट्स पर जो बीम की फोर्स ट्रांसफर्ड हुई है स्पोर्ट पर, या आप कह सकते हैं फुटिंग पर, तो फुटिंग जो फोर्स ट्रांसफर्ड है that is larger than the applied machine loading, or corresponding phase angle can be computed by this formula. The force transferring phase angle is this one. These expressions are given. ये इसका फेज एंगल का मैंने बताया था। ये दोनों में फार्मूला सेम है, चाहे वो ग्राउंड मोशन हो चाहे अप्लाइड लोडिंग की ट्रांसमिसिबिलिटी और ट्रांसमिसिबिलिटी का सेम एक्सप्रेशन है। तो इस तरह आप निकाल लेते हैं कितनी ट्रांसमिट हुई है फोर्स। तो ट्राई प्रैक्टिसिंग द अदर प्रॉब्लम आल्सो। ये एक एयर कंडीशनिंग का प्रॉब्लम है, इसको आप देख लीजिएगा। आई हैव आल्सो गिवन द रिकॉर्डेड लेक्चर इन द अदर, so try to see this problem also. It is not different, but it is a similar kind of problem. That air conditioning unit is placed on the beams. So you have the weight of the beam, clear span of the beam, the motor which is running, that उसकी frequency है आपके पास RPM में, and it produces an unbalanced force. Neglect the weight of the beam, 1% damping, E value. Determine the amplitude of the steady state deflection, acceleration also at their midpoint of the beam पे आपने इनका इफेक्ट देखना है, AC का जो पड़ा हुआ है। तो आपने यू कैन हैव द ओमेगा वैल्यू 300 RPM को कन्वर्ट करना है रेडियन में, डिवाइडेड बाय 60 मल्टीप्लाइड बाय द 2 पाई, सो दिस विल गिव यू द रेडियन। एंड स्टिफनेस ऑफ द टू बीम्स यू कंप्यूट ओमेगा, निकाल लिए। आफ्टर दैट द RD जो रिस्पॉन्स है, स्टेडी स्टेट रिस्पॉन्स, यहाँ पे बुक में डिफरेंट है, चोपड़ा की बुक में सिंबल्स और हैं। So RD is computed, that is equal to 1 over this one. This is the displacement response factor. Now from that आप ये U ही है बेसिकली, डिस्प्लेसमेंट जो एम्पलीट्यूड है इसको UST कर लें। तो U नॉट, दिस इज रिप्रेजेंटेड बाय U इन द मारियो पैज बुक। तो वहाँ से आपने U निकाल लेना है, ये U आ गया। यहाँ से आप एक्सेलरेशन निकाल सकते हैं, बिकॉज U इज लिंक्ड विद द एक्सेलरेशन, ओमेगा स्क्वायर U डॉट, यहाँ से आपका एक्सेलरेशन आ जाएगा। Similarly, these all the things that I have taught you, these are also given in your Mario Paz book, and some MATLAB program related to this chapter. So chapter number 1 we have studied, number 2 also. To discuss the MATLAB का जो program है, and then the program that we for the damped system, number 2. For the damped system you have the also the some MATLAB programming there. तो ये 4 ग्राफ हैं प्लॉट करने। In chapter number 3 this was all were proved. Some symbols may be different from the class lecture, but it is, you can read this if you want to see the detailed proof of the different formula, and please make a good comprehensive formula sheet so that it's clearly understood to you the response क्या है किस system का, and you can use that formula sheet in solving the problems. ये सारे प्रूव हैं, ये डायनामिक हमने पढ़ा है, जितने भी प्रॉब्लम ये सारे आप करें. We have done all that. Some part is left. ये मैं बाद में आपको एनर्जी वाला करवा दूंगा. ये MATLAB का प्रोग्राम है. ये जो प्रॉब्लम हम कर रहे थे उसको प्रोग्राम में अगर आप प्लॉट करें, इफ़ यू वांट टू प्लॉट दिस फंक्शंस, कौन से, इफ़ यू वांट टू प्लॉट सम ऑफ द फंक्शन ऑफ ट्रांसमिसिबिलिटी, ये जो सारे फंक्शन हैं ट्रांसमिसिबिलिटी एज अ फंक्शन ऑफ फ्रीक्वेंसी रेशियो, ये प्लॉट करने. So this program of the MATLAB, which is given on page number 63 of the Mario Pass, please read this. के different formulas ही हैं. frequency ratio आ गई, zeta value vary कर रही है, and you compute the different factors. ये denom है ना, ये सब expressions हैं, जैसे 1 minus beta square, it is a one function, 1 2 zeta r ये second function है, फिर एक और square root of these two, तो ये ट्रांसमिसिबिलिटी के फार्मूला में यूज होते हैं. So you compute all the individual factors, phase angle, and then transmissibility आ जाती है for different factors, and then you create the graph. So you will see, and you can create the transmissibility graph for different zeta value, for different frequency आप compute कर लें और different zeta के लिए plot कर लें इसका. So try working for the plotting these dynamic magnification factors. और भी अगर आप इसमें जो ग्राफ हमने देखें खुद से फंक्शन बनाकर वैल्यूज लेकर उनको प्लॉट करें और इन प्रॉब्लम्स को सॉल्व करें. सो इन योर एग्जाम ऑफ द मिड टर्म दीज फॉर दिस पार्ट विल बी इंक्लूडेड. इक्वेशन ऑफ मोशंस, बेसिक्स ऑफ द डायनामिक्स, डिफरेंट टाइप्स ऑफ लोडिंग्स, undamped free vibration, damped free vibration, forced vibration, undamped forced vibration, damped forced vibration, dynamic load factor, amplification factors, computation of the zeta value, logarithmic decrement. So all these parameters will be included. Okay, thank you very much. If you have any questions, you can ask.
Excuse me, sir.